Welcome back. In this video, we're going to talk about the general characteristics and definitions of acids and bases. We encounter these substances every day, from the food we eat to the cleaning supplies under our sinks. And they each have very distinct personalities in the lab and in nature. First, let's look at acids. The word acid comes from the Latin acidus, which literally means sour. You know this taste well if you've ever bitten into a lemon or a lime. That tartness comes from citric acid. In the lab, we identify acids using litmus paper, which turns red in their presence. And if you look at their chemical formulas, you'll notice they usually have a hydrogen written right at the front, like in hydrochloric acid. Bases have a very different set of traits. Instead of tasting sour, they taste bitter. Think of the unpleasant taste of soap. They also feel slippery to the touch. If you've ever accidentally gotten a bit of bleach on your finger, that slimy sensation is a classic sign of a base. A great way to remember their effect on litmus is the B rule. Bases turn litmus paper blue. B is for base, B is for blue. So, what's happening at the atomic level? The business end of an acid is the hydrogen ion, H+. Because a hydrogen atom is just one proton and one electron, when it loses that electron and becomes a positive ion, it is quite literally a bare proton. Because of this, we define acids as proton donors, substances that release these little H+ ions into a solution. On the flip side, the business end of a base is the hydroxide ion, written as OH-. Bases are ionic substances that dissociate in water to release this hydroxide. While we often identify them by the OH- ion, in chemical reactions we also describe bases as proton acceptors. They're looking to pick up the H+ ion that the acid is giving away. To wrap up, let's look at some real-world examples. Hydrochloric acid, HCl, is the gastric acid in your stomach that helps digest food. Sulfuric acid, H2SO4, is the battery acid used to start your car. You even find phosphoric acid in sodas like Dr. Pepper, giving them that sharp tart flavor. As for bases, sodium hydroxide, NaOH, is the active ingredient in heavy-duty oven cleaners, and potassium hydroxide, KOH, or potash, has traditionally been used to make soap. Now that we know what they are, in the next video we'll look at how they interact with each other.